Good day and welcome to HVAC 342. The purpose of this lecture is to talk about setting up a VVT system, excuse me, and talking about what they are, just so you kind of get a little feeling for it. VVT systems, variable volume, variable temperature, HVAC zoning system. What this is typically used with is with an existing non-variable volume rooftop unit or constant volume distribution unit of some sort, and you add dampers to this system. Each damper would be its own zone, and then we'd have to run some ductwork downstream of those dampers, and it gives us a kind of inexpensive way to zone a building. What I'm going to do here to help you out with this a little bit is make this a little bit larger, go into systems, and if I go into existing systems here and I go and hit the F1 key for help, it will open up this page here, and we can pick the different types of equipment: undefined, packaged rooftops, packaged vertical units, split air handling units, chilled water units, and terminal units, and it gives us information about different systems. Now for this Lab 8, you're going to be doing a VVT system. You're going to have a chilled water unit with a VAV system, and you're going to be going to a VRF system. This is going to be a short lecture just on VVT. So when we look at VVT systems, they're actually pretty simple. Let's kind of go through. First of all, you can open this up and read this, which I highly recommend that you do that. But in a nutshell, this is how this system works. This part here would be an existing rooftop unit. We have a supply fan, DX coil, natural gas combustion, heat exchanger in it, and we have return air damper, outside air damper, and relief air damper. Now what's going on is I've got a constant volume rooftop unit going on, so that thing is either going to be in heating or cooling. It's going to be ventilating or not ventilating. Then in the building itself, I'll have multiple zones. We have to determine how many zones we would have. So let's say that we're going to have 5 zones total, which is not correct for the lab, but in the 5 zones, each one of those zones would have a VVT box. Each box would have a thermostat, and they could have a CO2 system. And oh, by the way, VVT is a Carrier trademark item. Trane has a system like this. There's virtually lots of them. Honeywell has one. There's all kinds of knockoffs on this. This is because the boxes are relatively inexpensive, and because typically I go with a constant volume, inexpensive rooftop unit. What we're really doing is we're making this rooftop unit, we're zoning it out. And some of the problems we can run into with this is if I have a lot of zones that are not calling for heating and some that are heating, and I put the unit in heating mode, if I don't get enough airflow across my heat exchanger here, I will stress the heat exchanger and crack it. And conversely, if I don't get enough airflow across a cooling coil, I would end up freezing the coil up, and then it'd have to be defrosted in order to get airflow going across it again. So how this system works is simple. I've got a bunch of boxes. Again, let's talk about 5 of them. Let's say that out of the 5 boxes that are on this, that are down here a little bit, 3 of these boxes are calling for heating right now. These 2 are not calling for heating or cooling. So what happened is the control system would index the unit and say, let's go to heat because I've got 3 zones that need heat. So when I do that, if it's a single stage unit, I'll bring and you get the full heating capacity out of the rooftop, and air would be coming across down here. It could not go through these 2 dampers because they're closed, because I'm not calling for heating. It would go down the ductwork and go into the rooms themselves or into the zones themselves. Now what tends to happen is if I don't get enough airflow across here, instead of stressing the heat exchanger here or freezing the coil, I would be monitoring duct pressure. And as I'm doing that, and the duct pressure gets past a certain threshold indicative of not having enough airflow, we would go ahead and index or open up a bypass damper. So again, if I'm in heating and I'm putting out 105 degrees, 100 degree air coming across here, and I don't have enough airflow, let's say out of the 3 boxes we can't see, another one closes down, and now we're down to 2 of them, we would start bypassing hot air into the return stream. Some of it would go out in relief, but some of it would come in here. So now we're preheating the air going into the coil, which makes my delta T even lower. What tends to happen when I start running in bypass mode with these is I start cycling this equipment pretty hard. So this equipment it's inexpensive. Excuse me, the VVT system is inexpensive. The boxes are inexpensive. The ductwork is inexpensive for doing them typically. When we go ahead and we have a lower cost unit here, and we actually beat it up pretty hard. So this is, some people call it a poor man's VAV system, but realistically, if I have a building that's set up and they want to add zoning, it can work out for the customer. Realizing that the equipment's going to wear out probably prematurely, but they'll have temperature control and ventilation in there. Another thing that will happen when the units don't call for heating or cooling, they go to ventilation mode, and they just go to a predetermined position, and they just sit there, and the unit would not be adding heating or cooling. It would just be having some outside air coming in, and it would just end up letting the temperature float from that. But you can find that as you go through and read this. So I'm going to minimize this and start talking about the inputs that we do. First thing we're going to do is I'm going to hit cancel here, and I'm going to make a new system up. And I'm going to make it a VVT. Now, we already know we're going to use this existing rooftop. So I'm going to right click on it, duplicate it. And I'm going to rename this, and I'd recommend you do this with all of the systems that you're doing, all three of them, is I would go Med Center VVT System. Oops. All right, and what we're going to end up doing here is we're going to use a package rooftop, but instead of being a single zone, we're going to pick VVT here. And we're going to go through and put the number of zones, and I'm going to put in 3 zones, which is not correct for this project, but I'm just going to put in 3 zones. Once I get that done, we'll go to System Components. It's the same rooftop unit we've done before. Let's make sure we've got an economizer. Let's put our economizer in not integrated dry bulb. Our ventilation, let's go ahead and do scheduled ventilation, and let's pick a schedule, and I'm just going to pick one of these right here, which is not correct, but I'm just picking one anyway. Then we're going to go into central cooling, which will be DX. Now in the lab itself, you will find different temperatures and different things listed in here. And what I would do if I was you is I would print this off, and as you go through, just highlight the things that you've got done. Like for example, it talks about having a cooling of 57 and heating of 100 degrees. So we want to just make sure we set all these up, and all of these items should be able to be found in this setup here on the different pages. So I'm going to go back into here. I will put this at 57 because that's what it said there. When I go to heating, I got to change this back to combustion natural gas, and I believe this was 100 degrees. What I didn't notice was what the static pressure for the fan is. I'm going to set it at 1.5 just to give it a number, but make sure you check that out. On the duct system, I did put in a duct leakage rate on this. So with this one here, I think it was 6%, but you want to make sure you verify that. And this does have a return plenum, and I believe we were about that percent with it. Under zone components, you can see that it put every space in zone 1. There's 3 zones made up. There's zone 2 with nothing and zone 3 with nothing. I'm going to go to zone 1 and I'm going to empty it. And I'm just going to go ahead and hit shift and remove all of them. So I'm going to go 100 through 106. I'm going to put in zone 1, and I am just, again, this is not the right way to do it, but you determine from your assignment 4 what spaces go in which zone, and you go ahead and do that. Now 107 is going to have its own electric heater, so I'm going to go 108 through, and I'll stop at phlebotomy. That'll be in zone 2, and then zone 3 we'll put the rest of the building in. So now we've gone ahead and zoned the building out with spaces. When I go ahead here, then I can, this is where we set up each of the zones. So I believe we wanted to have 74 and 72. Now one thing I didn't tell you is this is clicked, so when by making these changes like this, it changes them for each zone. So if I go to zone, if I uncheck this, I can go to zone 2 and zone 3, and you can see that I've got the correct set points here. I know the bathroom had direct exhaust on it, so we'd want to put in what that was, and there was some fan energy for that also. And I'm just throwing a number in. It's probably not correct, and that's okay. but I want you to go off that sheet and find the correct one there. And then I'm going to go through and I'm just going to pick medical center CAV thermostat for right now. And this is where this thermostat you would have, or this thermostat schedule you would have made earlier. Then we've got supply terminals. Now with these here, I can uncheck this. I can go to zone 1, 2, and 3. Each one of these are VVT units. I did put in here and have you put a minimum airflow in of 1.5, I believe it was, air changes per hour. And that's just going to keep air movement through the space. I did not have you do that before, I don't believe, but typically when we have a zoning system, we end up putting these in. If we have a rooftop unit, usually on a rooftop, the fan is cycled on and off with space temperature. It can be left on though, or it can be programmed on. In addition, I went ahead and I had you put in a safety factor of 10%. So this is going to buffer our loads by 10%. And then on the equipment side, this defaults to carrier default efficiencies. So you're going to have to change this back to, I can't recall if this was 7 or 8% or 8 EER. I just don't recall what that was. And on the heating side, I know it was less than 85. I think we had 78 in here. And what this miscellaneous electric for is for that combustion blower outside. And I don't believe I had you put that in the other lab, but we'll put that in here. And so then I would go ahead and I would hit OK with that. And we'd end up in here with a VVT system. And just like we did before, you could go ahead and run this. As a matter of fact, I'm asking you in this lab is to include some information with this. So I'm going to hit a preview. And I'm going to pause this until this is done. So this just came back and it gives me a couple of reports here that I wanted to see as far as ventilation air and what we had for a system report. So that's creating relatively quickly a VVT system. So what I'm going to do now is go back to the lab. And in our lab here, once again, I know I've said this a couple of times, but what I'd like you to do is go through and you should be able to set up all of these various items in there. And if you have any questions, as usual, just send me an email and I will respond to that quickly. So with that, I'm going to end this lecture on VVT and you're going to have a couple other ones to look at for this lab. Thank you.